Hello students. We'll be discussing the questions of NEET 2025. So today we'll be discussing questions of NEET 2025 that happened on 4th of May. So 4th of May, the paper. So we'll be discussing the questions of chemistry. So my name is Varun Arora and I'll be discussing the questions of chemistry for NEET 2025. So let us start with the first question. Identify a suitable reagent for the following conversion. So this is an ester. We have to convert this into aldehyde. So if we are using a reducing agent like lithium aluminium hydride or NaBH4, so these reducing agent will reduce the ester to alcohol. So over here, if reduction is taking place, then alcohol will be formed. Now with hydrogen, palladium, barium sulfate also, reduction of esters will give me alcohol only. So isobutyl aluminium hydride. So this is isobutyl aluminium hydride, which is a weak reducing agent that is specifically used for reduction of esters into aldehyde and ketones. So it will not do the further reduction because it is a weaker reducing agent like lithium aluminum hydride or NaBH4, and it will only reduce the esters till aldehydes or ketones. So this is specifically used for reduction of esters to aldehyde or ketone. So answer will be fourth option. Next question. The correct order of decreasing acidity of the following in the aliphatic acids. So in carboxylic acid, the acidity will depend upon the strength of the stability of the conjugate base. So the alkyl group, more is the inductive effect, less stable is the conjugate base. So inductive effect will destabilize the conjugate base. So formic acid, hydrogen will be the formate ion will be the most stable conjugate base. So formic acid will be the strongest acid. So as the size of the alkyl group is increasing, CH3 whole twice, then CH3 whole thrice, the inductive effect will increase, and that will destabilize the conjugate base and the acidic strength will decrease. So more stable is the conjugate base, more is the acidic strength. So formic acid will form formate ion, which is the most stable conjugate base, and that acid will be the strongest. So as the size of the alkyl group is increasing, the acidic strength will decrease. So answer will be first option. Next question. So which of the following does not belong to the Lassen's test? So Lassen's test is basically used to detect halogens, then nitrogen and sulfur in organic compounds. So the first step is to put a piece of metal with the organic compound. So organic compound will have carbon, then to detect the presence of other elements like halogens, nitrogen and sulfur. Organic compound, in that organic compound, so a piece of sodium metal is added and heated. So the basic function of the sodium metal is to convert the halogens into their ionic form. So halogen is getting converted into ionic form. Similarly, if the organic compound is having nitrogen, that is also combining with carbon and nitrogen to convert it into its ionic form. Similarly, if the organic compound is having sulfur, so that will combine with sulfur also to convert it into ionic form. So which of the following does not belong to the Lassen's test? Lassen's test, the first step is addition of sodium metal and convert these halogens, nitrogen and sulfur into their ionic form. So which of the following does not belong is the second option. It is not a part of Lassen's test. Next, question number 4. If the rate constant for the reaction, so rate constant for the reaction is given 0.03 second inverse. So, and then how much time does it take for 7.2 moles per liter concentration of reactant? So initial concentration of reactant is 7.2 moles per liter to reduce to final concentration, that is 0.9 moles per liter. Now over here, if you see, the order of reaction is not given. So order of reaction is not given. Then how will you check whether this is right or wrong, or basically whether how will we do this question? How will we find out the time? Because for that we need the order of reaction or the equation that we have to use. Like for zero order, the equation is different. For first order, equation is different. So over here, from the units of rate constant, so the units of rate constant is giving me the information about the order of reaction. So units of rate constant is giving me the information about order of reaction. So units of rate constant is second inverse or time inverse. That means this is first order reactions. Clearly this is a first order reaction. Now we'll be using the equation for first order and we'll do this question. So Kt is equal to ln A naught by, so initial concentration by final concentration. So we have to find out time. Rate constant is 0.03. So 0.03 time we have to find out. So from here we'll get the time in seconds, and ln 7.2 divided by 0.9. So this is ln 8, that can be written as 3 ln 2. So time from over here will come out to be 3 ln 2 by 0.03. So 100 ln 2. So in the question the value of log 2 is given, that you can use, or if you remember the value of ln 2 is 0.693, that you can use directly 0.693. So 100 into 0.693. So putting the value of ln 2 0.693, you will get the time to be 69.3 seconds. So you will get the time to be 69.3 seconds. That is the third option. Next question. Given below are two statements. Statement 1, a hypothetical diatomic molecule with bond order 0 is quite stable. So if the bond order of any diatomic molecule is 0, so if bond order is 0, that means there is no bond between the two atoms. So bond order 0 means the molecule does not exist. So practically it will not exist, so it is not stable. So this statement is wrong. So bond order 0 is quite stable, this statement is wrong. Now as the bond order increases, so bond order increases, bond energy will increase and bond length will decrease. So bond length is inversely proportional to bond order. So as the bond order increases, bond length increases. This is also wrong. So as the bond order increases, bond length decreases. So both statement 1 and 2 are false. Next question. Out of the following complex, which of the compound will have the minimum conductance in the solution? So conductance will depend upon the number of ions given by the electrolyte. So if the electrolyte is dissociating into more number of ions, more will be the conductance. So over here you can see there will be 3 plus 1, 4 ions. It will dissociate into 4 ions. It will dissociate into 2 ions. So in these two complexes, both the chlorine atoms are in the complex, coordination complex. So they will not dissociate. So this will not dissociate. So you can call it single ion, or basically these are not ions. So actually in the question, both 3 and 4 options are correct because the number of ions are same. So ideally both 3 and 4 should be the answer for this question. Which of the following aqueous solution will exhibit highest boiling point? So elevation in boiling point will be Van 't Hoff factor into Kb into m, that is molality. So over here we are assuming these are dilute solutions only, 0.01, 0.015, 0.01. So we can assume molality to be molarity for dilute solution. So the elevation in boiling point will depend upon the factor, that is I and m, molality or molarity you can take over here, I and capital M we will be taking. So product of this will give me so higher value of Im will be the boiling point of that compound. So we are checking. So I over here, Na2SO4, the I will be 3, C6H2, sugar, the I will be 1, it will not dissociate. Urea also I is 1. For potassium nitrate, I is 2. So I into M 0.01, though that is 0.03. I into M 0.015, that is 0.015. I into M, that is 0.01, so this is 0.01. I into M, that will be 0.01, so this is 0.02. So highest value of Im will give me the highest elevation in boiling point, and that will have the highest boiling point. So answer will be first option. Next question. Given below are two statements, one is labeled as assertion, another is labeled as reasoning. So assertion is saying this compound 1, 2, 3, 4 carbon atom C4H9 iodine, so undergoes SN2 reaction faster than this. So SN2 reaction, what is the mechanism? A transition state will be formed and nucleophile will attack from the back. So since iodine is a good leaving group, so iodine will be leaving faster than chlorine. So SN2 reaction will be faster with iodine as compared to chlorine with the same nucleophile. So assertion is correct. Iodine is a better leaving group because of its large size. So reasoning is also correct, and reasoning is the correct explanation for assertion. So both assertion and reasoning are true, and reasoning is the correct explanation of assertion. So answer is 3. Next question, consider the following compounds. So atoms are underlined. The oxidation state of the underlying elements in them are. So over here, what will be the oxidation state of potassium? So this is KO2, potassium peroxide. So potassium will be in +1, oxygen is peroxide, O2 will be in the -1, or oxygen in -1/2 basically. So the oxidation state of potassium over here is +1. Hydrogen peroxide. So potassium superoxide, oxidation state of potassium is +1, and oxygen O2 is -1, or you can say each oxygen will be in -1/2 oxidation state, potassium superoxide. Then hydrogen peroxide, hydrogen will be in +1, O2 -2, and each oxygen will be in -1 oxidation state. So what is the oxidation state of oxygen over here? -1. H2SO4, the oxidation state of sulfur is +6. So potassium +1, oxygen -1, and +6 for sulfur. Answer will be third option. Next question, match the list 1 with list 2. So Haber's process. So Haber's process is used for manufacturing of ammonia. Over here, iron is used as a catalyst. Then Wacker's oxidation is basically used for oxidation of aldehydes and ketones. So over here, it is oxidation with palladium as catalyst. So palladium chloride is used in Wacker's oxidation. Wilkinson catalyst, the catalyst is basically Wilkinson catalyst is used for oxidation of alkenes and alkynes, or hydrogenation of alkenes and alkynes. So Wilkinson catalyst is rhodium chloride, tris triphenyl rhodium chloride. So this is Wilkinson catalyst. And Ziegler-Natta catalyst. So Ziegler-Natta catalyst or Ziegler catalyst is used in polymerization. So in this, titanium chloride with aluminium, alkyl aluminium. So this is the Ziegler-Natta catalyst. So A1B2 C3D4. Answer will be first option. Next question. Statement 1, like nitrogen can form ammonia, arsenic can form arsine. So nitrogen is forming ammonia, it is forming hydride. The hydride of nitrogen is ammonia. Similarly, arsine is the hydride of arsenic. So statement 1 is correct. Antimony cannot form antimony pentoxide. So antimony cannot form antimony pentoxide, that is Sb2O5. So Sb can show +5 oxidation state. So antimony can form antimony pentoxide. So statement 2 is incorrect. So answer will be first option. Statement 1 is correct and statement 2 is incorrect. Next question. Ferromagnetism is considered as an extreme form of paramagnetism. Number of unpaired electrons in chromium +2 ion is the same as that in niobium +3 ion. So first statement, ferromagnetism. What is ferromagnetism? So it is basically, you can say more is the number of unpaired electrons, the paramagnetic substance will be called as ferromagnetic. So ferromagnetism is an extreme form of paramagnetism. So that statement is correct. Now number of unpaired electrons in chromium +2. So chromium is 4s1 3d5. So chromium +2 will be 4s0 and 3d4. So 3d4, there are 4 unpaired electrons. And niobium +3, so +3 atomic number is given. So you will find the electronic configuration 6s2, then 4f4 will be there. 4f4, this is the electronic configuration. Then after removing 3 electrons from over here, so this will be 4f3. It will have 3 unpaired electrons. So the number of unpaired electrons is not same. So this statement is incorrect. Number of unpaired electrons is not same. So statement 1 is true, statement 2 is false. So answer will be first option. Next question, which of the following does not give benzene as the product? So red hot iron tube, ethyne, that is acetylene, will give benzene. This is one of the method for preparation of benzene. Then this benzene diazonium chloride with H2O, that will give me phenol. So in this case, benzene will not be formed. phenol will be formed. And decarboxylation, so sodium salt of carboxylic acid, this will undergo decarboxylation and benzene will be formed with sodium carbonate. And molybdenum oxide, so this will undergo polymerization. So hexane will undergo polymerization and dehydrogenation to give me benzene. So this method is also used for preparation of benzene. So which of the following does not give benzene will be second option. It is giving me phenol. Next question, XeO3. So xenon bonded with 3 oxygen atom and there will be 1 lone pair. Now what will be the hybridization? Hybridization sp3. So 3 bond pair, you don't have to consider the pi bonds. So 3 bond pair and 1 lone pair. The hybridization will be sp3. With 1 lone pair, the shape is known as trigonal pyramidal. So sp3 hybridization with trigonal pyramidal shape. So A is corresponding to 2. Then XeF2. So xenon is bonded to 2 fluorine and 1, 2, 3, 4, 5, 6. 6 electrons, total 8 electrons xenon is having. So 3 lone pair and 2 bond pair. Total 5, hybridization sp3d hybridization. sp3d hybridization with 3 lone pair and 2 bond pair, the shape is linear. So sp3 hybridization with 3 lone pair and 2 bond pair, the shape is linear. So sp3d with linear shape. So B is corresponding to 1. Then XeOF4. So XeF4 xenon will be forming a double bond with oxygen and 4 single bonds with fluorine. Total 6 electrons. So 1 will be the lone pair. So 1, 2, 3, 4, 5. 5 bond pair and 1 lone pair. Total 6. sp3 D2 hybridization. With 1 lone pair, the shape is square pyramidal. So sp3 D2 hybridization, square pyramidal shape. So C is corresponding to 4 and D will be corresponding. So D is XeF6. So there are 6 fluorine bonds and 1 will be the lone pair. So 6 bond pair and 1 lone pair. 1, 2, 3, 4, 5, 6. So 6 bond pair and 1 lone pair. Total 1, 7. Hybridization will be sp3dt hybridization and that is distorted octahedral. So D is corresponding to 3. So A2, B1, C4, D3. That is third option is the answer. Next, how many products including stereoisomers are expected from monochlorination of the following compound? So we are doing the monochlorination of the following compound. So first of all, I am doing chlorination of any one of this hydrogen. So these 6 hydrogens are equivalent. So any one of this I am replacing by chlorine. C2H5. Now over here on replacing this by chlorine, this carbon will become chiral. So over here you have to count including stereoisomers. Including stereoisomers, you will count this as 2. So these 6 are equivalent. Then I am replacing this hydrogen with chlorine. So when I am replacing this hydrogen with chlorine, the carbon is not chiral because these 2 are CH3 groups. So this is counted as single compound. Now I am replacing this hydrogen with chlorine. So on replacing this hydrogen with chlorine, the carbon, this carbon is chiral, it will show 2 optical isomers. So this will be also counted as 2. And the last one, so in the last one I am replacing this hydrogen with chlorine. So there is no chiral carbon in this. So this will be counted as 1. So total will be 2 plus 1 plus 2 plus 1, that is 6. So answer will be 6. Next question. Which of the following statements are true? So you have to tell. Unlike gallium that has very high melting point. So this statement is false because the gallium, the melting point is around room temperature, between around 30 degrees Celsius only. So gallium does not have very high melting point. So this statement is false, not true. Over here it is false only. So cesium also has very low melting point, but gallium also has very low melting point. It is not very high. So this statement is false. Then on Pauling scale, electronegativity values of nitrogen and chlorine are not the same. So almost you can say the electronegativity values of nitrogen and chlorine are almost same. So this statement also we will consider as false. Then argon, potassium chloride, calcium sulfide, RR. So isoelectronic species. So argon atomic number 18. So there are 18 electrons. Potassium 19. So potassium ion 19 minus 1, 18 electron. Chlorine atomic number 17. Chloride ion 17 plus 1, 18 electrons. Calcium atomic number 20. So calcium plus 2, 20 minus 2, 18 electrons. Sulfur atomic number 16, 16. Sulfide 16 plus 2, 18 electrons. So these all are isoelectronics. So this statement is true. So C is true. Then the correct order of first ionization energy. So sodium, magnesium, aluminium, silicon. So electronic configuration of sodium is 3s1. This is 3s2. This is 3s2, 3p1. This is 3p2. So along the period, effective nuclear charge increases, because of which the atomic radius decreases and ionization energy increases. So what is the order? Ionization energy increases along the period as the size is decreasing. But because of half-filled configuration, the ionization energy of magnesium will be greater than aluminium. So because of half-filled configuration, magnesium is 3s2. The ionization energy of magnesium is greater than aluminium. So this will be the correct order. So this statement is false. Last statement. The atomic radius of cesium is greater than that of, so down the group atomic radius is increasing. So lithium, potassium, lithium, sodium, potassium, rubidium, cesium. So down the group cesium will have the highest radius. So atomic radius of cesium is greater than that of lithium and rubidium. So this statement is true. So which one are true? C is true and E is true. So C and E are true. That is fourth option. Next question. The standard heat of formation in kilocalories per mole of barium ion is, enthalpy of formation of barium ion we have to find out in kilocalories per mole. What is given? Standard heat of formation of sulfate ion is given. Standard heat of crystallization of barium sulfate. So what is crystallization? So when barium plus 2 ion and sulfate ion will crystallize to give barium sulfate, the standard heat of crystallization, basically enthalpy of this reaction is given, that is minus 4.5 kilocalories per mole. So this is given, and standard heat of formation of barium sulfate is given. So if you consider this reaction, enthalpy of this reaction will be enthalpy of formation of product minus enthalpy of formation of reactant. So enthalpy of formation of product, that is barium sulfate, is already given. Enthalpy of formation of product minus enthalpy of formation of reactant. So what are reactant? Barium plus 2. Enthalpy of formation of barium plus 2, we have to find out, let that be x kilocalories per mole. All the values are given in kilocalories only. So let the value of enthalpy of formation of barium plus 2 that we have to find out is x kilocalories per mole. Then enthalpy of formation of sulfate ion is how much? Minus 216 kilocalories per mole. So that should be equal to minus 4.5. So minus 349 minus x plus 216. This minus and minus will become plus. That should be equal to minus 4.5. So x will be equal to minus 349 plus 216 plus 4.5. So minus 349 plus 220.5. So this will come out to be minus, solve it, minus 128.5. So this will come out to be minus 128.5 kilocalories per mole. That is option 3. Next question. Match the list. Humidity. What is humidity? Water vapors in air is humidity. So humidity is nothing but water that is liquid in air that is gas. So A is corresponding to 2, liquid in gas. Now alloys. Alloys is a mixture of two different metals. So solid in solid. Alloy is an example of solid in solid. So B is corresponding to 1. Amalgam is mercury. Mercury is liquid. So liquid in solid is amalgams. So C is corresponding to. So amalgams are basically the mixture of mercury with any metal. So liquid in solid, that is amalgams, are liquid in solid. And smoke is dust particles which are solid in air, that is gas. So smoke is solid in gas type of solution, that is 3. So A2, B1, C4, D3, that is 4th option. Carbon solid plus 2 hydrogen is giving me methane gas. Enthalpy of this reaction is given. Enthalpy is negative, that means it is exothermic reaction. So enthalpy is negative for exothermic. So that means enthalpy of any reaction is enthalpy of product minus enthalpy of reactant, that is negative. That means enthalpy of product will be less than enthalpy of reactant. So for exothermic reaction, enthalpy of product is less than enthalpy of reaction. Enthalpy of product is less than enthalpy. But this difference should be equal to minus 78.4, not this distance. This difference will be activation energy. So this enthalpy should be equal to minus 78.4. So first option is not fully correct. Then second option, enthalpy of product should be less than. Here the enthalpy of product is less than, more than reactant. So this is also not correct. So this is also not fully correct. Over here, enthalpy of product is less than enthalpy of reactant by a value equal to 78.4. So this is the correct diagram to represent this exothermic reaction. And over here also enthalpy of product is greater than reactant. So this is also not correct. Next question, sugar X is found in honey. So generally the sugar is glucose, fructose found in honey. Now it is a ketose sugar. So glucose is a aldose sugar, ketose sugar is fructose, and it can be sucrose also, but it exists in alpha and beta anomeric form. So alpha and beta anomeric form, that is shown by the fructose, and it is levorotatory. Fructose is levorotatory. So it confirms that it is fructose only. Total number of possible isomers, both structural as well as stereoisomers, of cyclic ethers of molecular formula C4H8O. So with molecular formula C4H8O, we have to draw cyclic ethers, only cyclic ethers, including stereoisomers. So with 4 carbon atom and oxygen atom, so this is the first cyclic ether. Then second one, we can have cyclic ether like this with one CH3 group like this. Then we can put this CH3 group over here. So including structure, so these two are structural isomers. Now over here, this carbon is chiral. This carbon is chiral, all the 4 groups are different. So this will be counted as 2 because it will show 2 stereoisomers. Then we can have ether with 3-member ring. With 3-member ring, there can be C2H5 attached like this. There can be 2 CH3 attached like this. Then there can be 2 CH3 on the different carbon atoms. So this is the possibility. Over here also, if you see, this carbon is chiral, this will be counted as 2. Now this carbon is not chiral, the 2 CH3 is same, so this will be counted as 1 only. And over here, this carbon is chiral, this carbon is also chiral, but the molecule is symmetrical. So with 2 chiral carbon, symmetrical molecule, this will be counted in number of stereoisomers as 3. You can use the formula. So 2 raised to power n minus 1 plus 2 raised to power n minus 1 by 2. That will be the total number of stereoisomers for this. That will be 3. So total number of stereoisomers we have to count. So 1 for this, then 2 for this, then 1 for this, then 2 for this, then 1 for this, and 3 for this. So 3, 4, 5, 7, and 3, 10. So total number of stereoisomers are coming out to be 10. So the only cyclic ethers we have to make. So this is counted as 1 only. This will be counted as 2 stereoisomers, chiral carbon. This is counted as 1. This is counted as 2 stereoisomers, chiral carbon. This is counted as 1. Over here there are 2 chiral carbon. Total number of stereoisomers will be 3 using the formula 2 raised to power n minus 1 plus 2 raised to power n minus 1 by 2. N is even over here. Total number of stereoisomers are given by this formula, where n is the number of chiral carbons or stereo centers. So answer for this is 10. Next question. For the reaction A gas is in equilibrium with 2B gas, the backward reaction rate constant is higher than the forward reaction rate constant by a factor of 2500. So backward reaction rate constant is higher than the forward reaction rate constant by 2500. So for any equilibrium, so A is in equilibrium with 2B. So rate constant for forward, rate constant for backward. So equilibrium constant will be rate constant for forward divided by rate constant for backward. Now rate constant for backward reaction is higher than forward reaction. So backward reaction is 2500 times higher than forward reaction. So rate constant for backward is 2500 times the forward reaction. So this rate equilibrium constant over here, that is Kc for this reaction, will be 1 upon 2500 at 1000 Kelvin. The Kp we have to find out. Kp is equal to Kc into RT power delta Ng. Now delta Ng for this reaction will be 2 minus 1, that is 1. Kc is 1 upon 2500, R value is 0.0831, temperature is 1000 and delta Ng is 1. So this will come out to be 83.1 by 2500. So this will be 0.033, that is first option. Next question. The ratio of wavelength of light absorbed by hydrogen atom when it undergoes n is equal to 2 to n is equal to 3 transition. So let the wavelength over here is lambda 1 and n is equal to 4 to n is equal to 6 transition. The wavelength is lambda 2. So we have to find out the ratio of wavelength, that is lambda 1 upon lambda 2. So 1 upon lambda 1 using the Rydberg's formula is Rz square, Z is 1 for hydrogen atom. 1 upon n1 square, that is 2 square, minus 1 upon n2 square, that is 3 square. So this will come out to be 9 minus 4, that 9 4s are 36, 5 by 36. So lambda 1 can be written as 36 by 5R. Similarly, using the Rydberg's formula for n is equal to 4 to 6, so 1 upon lambda 2 will be R, Z is 1 for hydrogen, 1 upon 4 square minus 1 upon 6 square. 4 square is 16 and 6 square is 36. So LCM of 4 and 6 is 12. So you can take LCM also. So over here 16 and 36, 4 into 4 and 4 into 9. So 9 4s are 36, 16, 72. So 72 you will take. 72, 16, 32, 7, 68. 72 is not a factor. So first of all, let us take 2 common from this. So I am taking 2 common from this. R, so 1 upon 2 square common, remaining is 1 upon 2 square minus 1 upon 3 square. Then you will solve this further. 1 upon lambda 2 will be R by 4. This will be 9 and 4. 9 4s are 36. So 5 by 36. So lambda 2 will be 4 into 36 by 5r. So 36 by 5r is lambda 1, 4 times lambda 1. So what we have to find out? Lambda 1 by lambda 2. Lambda 1 by lambda 2 will come out to be 1 by 4. So answer will be second option. Next question. If the molar conductivity of a 0.05 moles per liter solution of a monobasic weak acid is 90 Simon centimeter square mole inverse, its extent of degree of dissociation will be. So monobasic weak acid. So there is a weak acid. So monobasic weak acid for which the molar conductivity is given at some concentration. So at this concentration, molar conductivity is given how much? 90 Simon centimeter square mole inverse. So this is the molar conductivity that is given. Now degree of dissociation, extent of dissociation is molar conductivity by molar conductivity at infinite dilution. So molar conductivity is given in Simon centimeter square mole inverse, and for infinite dilution, so these values are given in the question. We have to use this. So 349.6 plus 50.4. So this will be 400, 90 by 400, 9 by 40, that will be 0.225. So answer will be first option. Degree of dissociation is 0.225. Next question. 5 moles of liquid X and 10 moles of liquid Y make a solution having vapor pressure of 70 torr. So vapor pressure of solution is 70 torr. That is mole fraction of A into P naught A plus mole fraction of B into P naught B, assuming the solution to be ideal. The vapor pressure of pure X and Y are 63 torr and 78 torr. Which of the following is true regarding the described solution? The solution is ideal. The solution has greater volume than the sum of individual volumes. The solution shows positive deviation. Solution shows negative deviation. So basically, let us first find out, assuming the solution to be ideal, let us find out the vapor pressure. So mole fraction of A will be moles of A divided by total, that is 10 plus 5, 15, into vapor pressure of pure A, that is 63, plus mole fraction of B will be 10 by 15 into vapor pressure of pure B, that is 78. So 321, 2, 3, 20, 2 and 6, 18, 3. So this will be 21 plus 26 into 52. So this will be 73 torr. So vapor pressure, assuming the solution to be ideal, should be 73 torr. But the actual pressure is less than ideal pressure. So actual pressure or the experimental pressure is less than the ideal pressure. That means it is showing negative deviation. So there is negative deviation in this solution. Next, among the following, choose the one with equal number of atoms. Choose the one with equal number of atoms. So molar mass is 106. So molar mass is 106 grams. Among the following, choose the one with equal number of atoms. So molar mass is given 106. Let us find out the number of moles. So mass is 212. Molar mass is 106. So the number of moles is 2. So number of atoms will now in one, these are number of moles. So number of molecules will be 2Na, and in one molecule there are 2 and 1 3 and 3 plus 3 6 atoms. So number of atoms will be 12Na in the first case. Now in the second case, number of moles will be 248, that is given mass by molar mass. So this is coming out to be 4. Number of moles are 4. Number of molecules will be 4Na, and in one molecule how many atoms? And 2 sodium and 1 oxygen, 3 atoms. So 4 3s are 12Na. Both are having same number of atoms. The ones with equal number of atoms you have to tell. So A is equal to B in number of atoms. Let us check the other options. NaOH, molar mass is 40. Number of moles will be 240 by 40, that is 6. Number of moles is 6. So that will be number of molecules is 6Na, and this will be 6 into So number of molecules is 6 Na. So that will be 6 Na into the number of atoms in this. So NaOH, there are 1 sodium, 1 oxygen and 1 hydrogen, 3 atoms. So 6 3s are 18 Na atoms are there. So number of atoms will be 18 Na. Now hydrogen, 12 by 2, that is 6. 12 by 2, that is 6 moles. So number of molecules 6 Na, and in one molecule there are 2 atoms of hydrogen. So 12 Na. So 12 Na is same for A, B and D. So these are having same number of atoms, equal number of atoms. Then let us check the last option. So carbon dioxide, number of moles will be 220 by 44. That is 10 by 2, that is 5 moles. So number of molecules 5 Na, and in one molecule there are 3 atoms. So 15 Na. So 15 Na, the answer will be. So these 3 are having equal number of atoms, A, B and D. So E and C are having different atoms. So answer will be A, B and D are having equal number of atoms. So that is option 4. Next, which of the following are paramagnetic? So paramagnetic, you have to tell nickel. All are complexes of nickel. Nickel atomic number 28, electronic configuration 4s2, 3d8. So 3d8, there will be 2 unpaired electrons. 1, 2, 3, 4, 5, 6, 7 and 8. So 2 unpaired electrons will be there. Now chlorine is a weak field ligand that will not cause pairing. So there will be 2 unpaired electrons. So that is paramagnetic. Now carbonyl, that is the carbon monoxide, is a strong field ligand that will cause pairing. So no unpaired electron will be there. So this will be diamagnetic. Cyanide is also strong field ligand. So no unpaired electron, it will also cause pairing. H2O is a weak field ligand, it will not cause pairing. So there will be 2 unpaired electrons. So this will be paramagnetic. And triphenyl phosphine is a strong field ligand that will also cause pairing of electrons of nickel. So there will be no unpaired electron, and this will be also diamagnetic. So paramagnetic with 2 unpaired electron are A and D option. So A and D only. If the half-life for first order reaction is 1 minute, so for first order reaction half-life is given out to be 1 minute. Then the time required for 99% completion of the reaction is closest to. So for first order, the reaction equation is Kt is equal to ln A naught by At. So 99% completion. So that means At will be 0.1% of A naught. 0.1% means A naught by 1000. So At we are putting A naught by 1000. So this will be ln 1000. So time we have to find out. So time is ln 1000 by k. So the value of half-life is given. So k is, for first order, k is ln 2 by half-life, or half-life is ln 2 by k. So half-life is 1 minute. So ln 2 by half-life, that is ln 2 by 1. This is the value of k we'll be using over here. So from here we'll get the time in minutes. So this is ln 10, 3 ln 10, 10 cube is 1000, divided by this is ln 2. Right? Now we are using the property of log. So log a to the base b can be written as log a to the base x upon log b to the base x. So over here base is same for both the log. So I am using the property of log. This can be written as log 10 to the base 2, and this can also be written as, if I am writing like this, ln 2 by ln 10. This will be also written as log 2 to the base 10. So if I am taking in the opposite direction, so this will become log 2, ln 2 by ln 10, I can write down log 2 to the base 10. So time is 3 by this, I am writing log 2 to the base 10 in the denominator. So ln 2 by ln 10. So log 2, the value is 0.3 approximately, exactly 0.3010. So we are taking 0.3. So this will become, time is coming out to be 10 minutes. So time will come out to be in minutes, because the units of time over here is minutes and the units of k will be minute inverse. So time will come out to be 10 minutes. That is second option. Next question. The energy and radius of first Bohr orbit of helium ion and lithium plus 2 ion are. So the energy and radius of first Bohr orbit of helium ion and lithium plus 2 ion we have to tell. So radius R is equal to R naught n square by Z. Right? So R naught or A naught value is given 52.9 picometer. So 52.9 into n for helium. First Bohr orbit n will be 1. And for helium plus 1 atomic number is 2. So 52.9 by 2 is how much? So this will be 26.45. So 26.4 radius of helium ion, 26.4 will be taking. Then radius of lithium ion, using the same formula 52.9, first orbit n will be 1 and for lithium Z is 3. So this will be 1 and 17.6. So 17.6. So these are the two values. 17.6. So option 2 is already eliminated. Then this option is also having these two values. This fourth option is already eliminated. Now let us check the energy of helium and energy of lithium ion. So energy value is given. So E is equal to E naught n square Z square by n square. So over here E naught value in terms of Rydberg's energy is given. So the value of E naught is 2.18 into 10 to the power minus 18 joules. So for helium, first orbit n will be 1, Z is 2, so 2 square is 4. So Z is 2 for helium, so 4 into 2.18, so approximately it will be 18 point, so 32, 4, 6, 8.62 into 10 to the power minus 8, 18 joules. So 8.72, sorry. 8.72 into 10 to the power minus 18 joules. This is the energy of helium. Not 10 to the power of 16, this is 10 to the power 18. So this option is already eliminated. And then you can find out this using the same formula, energy of lithium also. So this will be E naught, that is 2.18 into 10 to the power minus 18. Z is 3, so 3 square is 9 by 1. So square for this. So 9 into 2.18, that you will get 19.62 into 10 to the power 18. So answer will be third option. Next question, among the given compounds 1, 2, 3, the correct order of bond dissociation energy of carbon hydrogen marked with star. So over here this hydrogen is attached to carbon, that is sp2 hybridized. This is attached to carbon, that is sp hybridized. And this is attached to carbon, that is sp3 hybridized. So sp hybridized carbon, the electronegativity is more. So more is the electronegativity, shorter will be the or bond energy, or the bond dissociation energy will be shorter will be the bond length, and the bond dissociation energy will be maximum. So with more amount of electronegativity, this carbon will have the shorter will be the bond length and more will be the bond energy. So bond dissociation energy of this, which is sp hybridized, will be greater than sp2 hybridized, which is greater than sp3 hybridized. So bond dissociation energy will be the order this. Next question. Dalton's atomic theory could not explain which of the following? So Dalton's atomic theory was able to explain conservation of mass, law of definite proportion, that is constant proportion, and multiple proportion, but it was not able to explain the law of gaseous volume. That was not explained by Dalton. So answer will be second option. Identify the correct orders against the property H2O ammonia CHCl3 dipole moment. So H2O dipole moment because of two lone pair and bond angle is less. Dipole moment of H2O is greater than ammonia. That is correct only. And ammonia, the dipole moment will be greater than, because of one lone pair, the dipole moment will be greater than chloroform, that is CHCl3. So this is the correct order of dipole moment. Then XCF4, XCO3, XCF2, number of lone pairs. Number of lone pairs in XCF4 will be two lone pair. So there are two lone pair, total 4 electrons. XCO3, 6 plus 1 lone pair. XCF2, there will be 8 minus 2, that is 6, so 3 lone pair. So number of lone pair order is not correct. Then oxygen, hydrogen, carbon, hydrogen, nitrogen, oxygen, bond length. So bond length of oxygen, hydrogen, because of smaller size of hydrogen, oxygen, hydrogen bond length will be less than nitrogen, oxygen because of smaller size. So this is also not the correct order of bond length. Bond enthalpy. Nitrogen, there is triple bond, bond energy is more. Oxygen, the double bond energy is less. Hydrogen single bond energy is less. So this is the order of bond enthalpy. This is correct. So answer will be A and D. That is third option. So match the list 1 with list 2. Name of vitamin B12. That is B12 will cause anemia. Then vitamin D is basically used for rickets. The deficiency of vitamin D will cause the rickets, that is the bone deformations. Then vitamin B2 will cause chiliosis, that is the chiliosis or the dryness of the skin. Then vitamin B6, it is vitamin B6 that will cause convulsions. So vitamin B6 will cause convulsion. So A is corresponding to 4, B is corresponding to rickets, that is 3, C is corresponding to chiliosis 1, that is D is corresponding to conversion, that is 2. So A4, B3, C1, D2, that is fourth option will be the answer. Next question. The correct order of decreasing basic strength of the given amines. So amines are N-ethyl ethanamine. So what is ethanamine? This is ethanamine. Now N-ethyl. So there is one more ethyl group. So this is N-ethyl ethanamine. Then ethanamine. So this is ethanamine. Then N-methyl aniline. So aniline with methyl group. So this is N-methyl aniline. We have to arrange in order of their basic strength. Benzenamine. So benzenamine is nothing but aniline only. So in aniline, the lone pair is involved in resonance. So that is less available, that is less basic. But over here, because of plus I effect, the N-methyl aniline will be more basic than aniline, that is benzenamine. Now this is primary amine, this is secondary amine. So secondary amine will be more basic than primary amine. So N-ethyl aniline enamine is more than ethanamine. So this will be the correct order. First option. Next question. The correct order of wavelength of light absorbed by the following complexes is, so light is absorbed by the following complexes. So basically in the complex, the wavelength of light is inversely proportional to crystal field splitting energy of the complex. Now crystal field splitting energy will first of all depend upon the strength of ligand. So stronger is the ligand, more will be its crystal field splitting energy. More is the crystal field splitting energy, lesser will be the wavelength. Now according to the strength, cyanide is a stronger ligand than ammonia, which is a stronger ligand than H2O. So this complex will have more crystal field splitting energy. So wavelength will be less. So wavelength of B will be less than A. Then you will take C and D. C and D both are H2O. Now over here, this is tetrahedral, this is octahedral. So tetrahedral, the crystal field splitting energy is less than crystal field splitting energy for octahedral. So octahedral will have more crystal field splitting energy, so wavelength will be less. So wavelength of octahedral will be less than wavelength of tetrahedral. So this will be the correct order of wavelength, BADC. That is fourth option. Next question, which of the following compounds does not decolorize bromine water? So bromine water is the test for unsaturation. So alkenes and alkynes having double or triple bond will decolorize bromine water. So in this alkene, it will decolorize bromine water. In this also double bond is there, that will also decolorize bromine water. In this there is no double bond, so that does not decolorize bromine water. So that will be third option. Next question. Predict the major product P in the following sequence of reaction. So HBr in presence of peroxide. So peroxide effect will be there. So according to peroxide effect, it will be anti-Markovnikov of addition. So anti-Markovnikov of addition, the bromine will attach over here and hydrogen will attach over here, anti-Markovnikov of addition. So hydrogen will be attached to that carbon atom that is having less number of hydrogen atom and bromine to the other carbon atom. So anti-Markovnikov of addition will take place, HBr in presence of peroxide. Then KCN. So with KCN, this bromine will undergo substitution. So cyanide, Cn minus will attack and the bond will be through carbon of the cyanide. Bromine will undergo substitution, Cn minus ion will attack. So this will be the compound after second step. Now reduction. So reduction with sodium and ethanol. So reduction will take place. So reduction of cyanide will give me CH2NH2 group. So this will be the final product, that is third option. Next question. Mixture CH3Cl C6H5NH2, method of separation. So CH3Cl, there is no hydrogen bonding. Chloroform, there is no hydrogen bonding. In aniline, there is hydrogen bonding. So this mixture can be separated by a simple distillation because of difference in their boiling point. So because of hydrogen bonding, there will be difference in boiling point of chloroform and aniline, and they can be easily separated by simple distillation. Next, crude oil in petroleum industry is separated by a fractional distillation. So different fractions of crude oil is obtained at different levels. So crude oil is separated by fractional distillation. Then glycerol. Glycerol is separated from the spent lye by distillation under reduced pressure because this will lower the boiling point, and so glycerol can be easily separated at reduced pressure distillation. So C will correspond to 1, and D, that is aniline water. Aniline water can be separated by steam distillation because of difference in their boiling point. Steam distillation is used for aniline water. So A4, B3, C1 and D2, that is third option is the answer. Next question, which of the following electronic configuration belongs to the main group? So this is main group, group 1 element. So what are main groups? S and P block elements are main group elements. Then over here, this is D block element. So this will be not counted in main group. S and P we have to count main group elements. Then this also 5s2, 5p5. So this will be counted in main group. So A and C will be counted in main group. Now this 4s1, 3d10, that is copper. So that is D block, that will be not counted in main group. Then over here 7s2, then so this is D block element 6d2, 5f0. So this will be counted in, not counted in main group. So this will be not counted. So only A and C will be counted in main group. So A and C only. Next question, which of the following compounds can exist as cis-trans isomerism? So cis-trans isomerism is shown by which of the following compounds? 1,1-dimethyl cyclopropane. So cyclopropane with 2-methyl group. So since both the methyl groups are on the same carbon atom, this cycloalkane will not show geometrical isomerism. So for geometrical isomerism, the two alkyl groups should be attached to different carbon atoms. So suppose there was 1,2-dimethyl cyclopropane over here. This compound can show cis and trans type of geometrical isomerism. So this one will be cis and the other one will be trans. So when the two methyl groups are attached to two different carbons, this can show geometrical isomerism, but this one, since both the methyl groups are on the same carbon atom, this will not show geometrical isomerism. Then 1,2-dimethyl cyclohexane. So cyclohexane can also show geometrical isomerism when the two methyl groups are on the different carbon atoms. So you can draw the two geometrical isomers like this. So 2 CH3 group on the same side, 2 hydrogen on the same side. So this will be cis isomer, and the other one CH3 group and 1 CH3 group opposite, hydrogen opposite. So this one is cis, this one is trans. So this one can show cis trans type of geometrical isomerism. Pent-2-ene. Pent-1-ene. So pent-1-ene will not show geometrical isomerism. Both the groups are same on this carbon atom. Then 2-methyl-hex-2-ene. 1, 2, 3, 4, 5, 6. Hex-2-ene and 2-methyl. So on this carbon atom, both the groups are same. So this will also not show geometrical isomerism, cis and trans type. So answer will be second option. Next question. Phosphoric acid ionizes in 3 steps with ionization constant value as Ka1. So phosphoric acid H3PO4 will ionize in 3 steps. So first of all, it will give me H2PO4 minus. Then H2PO4 minus will further ionize to give HPO4 2 minus. Then HPO4 2 minus will further ionize to give phosphate ion PO4 3 minus plus H plus. So dissociation constant are Ka1, Ka2, Ka3. And the overall ionization constant is K. So K will be equal to Ka1 into Ka2 into Ka3. So you can take log Ka will be using the property of log. You can easily write down log K will be equal to log K1 plus Ka2 plus K3. So first statement is true. Then H3PO4 is stronger acid. So we know that as the dissociation, further dissociation constant, the value decreases. So Ka1 for any acid is always greater than Ka2 is always greater than Ka3. So first dissociation will be more. So more amount of H plus ion from the first dissociation. So you can say this is stronger acid than this. This is the conjugate base of this, and this will be weaker acid than this. So H3PO4 is a stronger acid than these two. That is also correct. And Ka1 will be greater than Ka2 is greater than Ka3. So A, B, C are correct. So D you cannot say. Ka1 is equal to Ka1 greater than Ka2. That is not, does not make any sense. So answer will be A, B and C. Next question. So match the list 1. List 1 ions are given. List 2 group numbers in cationic analysis. Cation analysis, group numbers we have to match. So cobalt is there in group 4. So cobalt is there in group 4. Magnesium is present in the group 6. So magnesium is group 6. Then lead is there in the group 1 and aluminium is present in the group 3. So A is corresponding to 3. B is corresponding to 4, that is group 6. C is corresponding to 1 and D is corresponding to 2nd. A, 3, B, 4, C, 1, D, 2, that is 4th option is the answer. Next question. The high yield of NO in this reaction, N2 gas plus O2 gas is giving me NO gas, can be obtained at, so delta H of the reaction is given. Delta H of the reaction is positive. That means this is endothermic reaction. Now, if I am increasing the temperature, what will happen? If I am increasing the temperature, the equilibrium will shift in the direction of endothermic. So, it will shift in forward direction, which is endothermic. So, equilibrium will shift in forward direction, that is endothermic direction. So, the yield of NO will increase. So, high yield of NO can be obtained by increasing temperature. So, higher temperature will be the yield of NO will be increasing, higher yield of NO will be there. Then if I'm increasing the concentration of N2, then also the equilibrium will move in the forward direction and yield will increase. Now if I'm increasing the concentration of O2, then also the equilibrium will shift in the forward direction and the yield of NO will increase. So answer will be ACD. Next question. Given below are two statements. Benzene diazonium salt is prepared by reaction of aniline with nitrous acid at 273 Kelvin to 278 Kelvin. It decomposes easily in the dry state. So benzene diazonium salt is prepared by reaction of aniline. So aniline is reacted with nitrous acid, HNO2. The temperature is 0 to 5 degrees Celsius, that is 273 to 278 Kelvin. So you will be getting benzene diazonium salt is made. That is correct statement only. It decomposes easily. It is highly unstable and decomposes easily. So statement 1 is correct. Now statement 2, insertion of iodine into the benzene ring is difficult, and so substitution with any group for benzene ring is difficult, and insertion of iodine by substitution mechanism is difficult. So you cannot prepare iodobenzene easily. So insertion of iodine in benzene ring is difficult, and hence iodobenzene is prepared through reaction of benzene diazonium salt. So from benzene diazonium salt, you can easily prepare iodobenzene. So generally this method is used for preparation of iodobenzene. So benzene diazonium salt is highly reactive, and on addition with Ki, that will give me iodobenzene. So this method is used. So that statement is also correct. So both statement 1 and 2 are correct. Both statement 1 and 2 are correct. That is third option will be the answer. Next question, the major product of the following reaction. So Grignard's reagent CH3MgBr, that will attack this carbonyl group MgBr plus and one CH3 over here, then CH2, then cyanide also. Carbon nitrogen bond will be polarized. Carbon will be at the positive charge. CH3 will attack over here. Nitrogen will be at the negative charge and MgBr plus. Now this on hydrolysis, acidic hydrolysis, this carbon oxygen bond will be, carbon nitrogen bond will be hydrolyzed. So over here ketone will be formed, and this will give me alcohol. So what is the final product? So this is the final product. So this carbon oxygen bond will be, carbon nitrogen bond will be completely hydrolyzed on acidic hydrolysis. So this will give me this ketone. So this will be the ketone over here formed. And so answer will be this option, fourth option will be the answer. So thank you.